Salutations, viewers across the world, ladies and gentlemen, comrades and friends. This is the Mathematics and Sciences Guru Chico Squared, Tinashe Obed Shikoko. And in this video, I'm going to be outlining the IGCSE syllabus for mathematics, which is the International General Certificate of Secondary Education, Cambridge. And the syllabus code we're going to be focusing is 0580. This is both for the core and the extended curriculum students. And it is my open belief that whatever we're going to be discussing in this lecture is going to sink deep into your cerebral hemispheres without much difficulty. So we're going to be having a series of lectures on the whole syllabus, the IGCSE. Once we're done, we're going to go to the AS, and then we're going to go to the A2. And we're going to be moving part by part. And in this specific video, we're going to be focusing on C1.1 in the syllabus, in the Cambridge syllabus. And this concept is called types of number, all right? So under this concept, types of number, according to the requirements of the syllabus, we're going to be specifically focusing on these following subtopics. The first one, natural numbers. The second one, integers. Third one, prime numbers. Fourth one, square numbers, cube numbers, common factors, common multiples, rational and irrational numbers, and also reciprocals as well. So we're going to start with the first aspect, which is natural numbers, all right? So let's ask ourselves, what are natural numbers, all right? Natural numbers are numbers that we use in counting, all right? They are also known as counting numbers, all right? Let me ask any of you, right? When we are counting, what are we going to do? We are starting from 1, 2, 3, 4, 5. Suppose we are given an object to count. We're going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Going onwards. We're not going to use fractions. I've never seen someone counting numbers and they say this is 1.5, 2, 2.5, 3. It's only whole numbers starting from 1. So these are what we call natural numbers. So natural numbers in mathematics denoted as the following, all right? These are whole numbers which are used for counting purposes. Remember, 0 is not included because 0 is not used in counting because the number 0 indicates that there's nothing available. So we are counting starting from 1, going to up to we reach to a point called infinity in mathematical language. So these are called natural numbers, all right? So my examples, they are natural numbers. We can say 7 apples, you can say 7 bananas, whatever you want. Or you can write in set notation, 7 is an element of natural numbers because it is part and parcel of the counting numbers. Right, second aspect, let's look at integers, right? So integers, right, by definition, right? Integers, by definition, we are talking about whole numbers, right? And these whole numbers come into 3 categories. You've got positive whole numbers, you've got negative whole numbers, and you've got 0. So literally speaking, we are saying integers, these are numbers that are found on the number line, all right? So the number line, you've got 0 at the center of the number line, and then you have positive numbers running right number line up until we get to positive infinity. And then we also have negative numbers running on the left of 0 up until we reach to negative infinity. So these are what we call integers. So integers, the difference between integers and natural numbers, as we have outlined, is that in natural numbers, we are starting from 1 up to infinity. Then integers include 0, and integers also include negative numbers in addition to the positive numbers. All right. Third aspect, number 3, prime numbers. What are prime numbers? Prime numbers are numbers that are exactly divisible by 1 and itself only, all right? A number that gets into another number without leaving a remainder in mathematics is called a factor. So precisely what we're saying is that an integer is a number that consists of only 2 factors, 1 and itself, all right? And if we are to list prime numbers, let's say, for instance, we are required to list all the prime numbers that are between 1 and 20, all right? So 2 is the prime number. Right? 1 is not a prime number. So 1 is not a prime number. Let me emphasize this. So 2 ndianotanga, followed by 3, followed by 5, followed by 7, followed by 11, followed by 13, followed by 17, right? And lastly, 19. That is my prime numbers are between 1 and 20, all right? And one thing to note is this. 2 is the only even prime numbers, all right? An even number is a number that is only exactly divisible by 2. Without number to 2 asingasi remainder. We're talking of 1, 2, 4, 6, 8, 10, 12, 14, 16, up until we get to infinity. These are called prime numbers. You understand? Okay. Let's look at the fourth aspect now. Square numbers. All right? So when we're talking of square numbers, we are talking about a number that is obtained by multiplying a number twice. All right? For example, if I say 1 times 1, I get 1. So 1 is a square number. Why? Because it is obtained by multiplying 1 twice. 2 times 2, we get a 4. 3 times 3, we get a 9. 4 times 4, we get a 16. 5 times 5, 25. 36, 49, 64, 81, 100. These are called square numbers. And why are we calling them square numbers? It's because these numbers are obtained after you multiply a number twice. You understand? So, ndoma numbers kuti tikadatsvaga ma square roots, all right? Square root are my square numbers, and then the square root whose a number actually has times are twice. So if you take a square number, let's take for instance 64. We know that 64 is obtained by multiplying 8 times 8, all right? So 64 is a square number, and the square root of 64 is 8. All right, don't mind about the square roots for the moment because it's also part and parcel of the syllabus. I think it's C.1.45, if I'm not mistaken. And we are going to get to that point where we are going to deliberate, dissect, dichotomize, elaborate, and elucidate these concepts so that they sink direct into your mental faculties without any difficulty. Chico squared. Hoyo. Chibabaichu. As we continue, viewers across the world, let's move on to the next aspect. Soon after square numbers, we also have what are called cube numbers. All right? My cube numbers, unlike my square numbers, these are numbers that are obtained after you multiply a number 3 times. For instance, 1 to the power 3, which is 1 times 1 times 1, gives you 1. Then 2 cube, 2 times 2 times 2 gives you 8. 3 cube, 3 times 3 times 3 gives you 27. 4 cube gives you 64. 5 cube gives you 125. So my numbers were soon after multiplying a number itself 3 times. These are called cube numbers. All right, in the next episode, we are going to be talking about the cube root. All right. So the cube root, we are talking about the number. Yet 2 times or 3 times we still arrive at that particular cube number under consideration. All right. Next one. We are now looking at factors. All right. A factor is a number that gets into another number without leaving a remainder, or we can define it as a number that divides exactly into another number. And the division exactly we're talking about getting into a number without leaving a remainder. And for instance, let's take a number like 12, all right? Right, I just chose the number 12 because it's a unique number. Jesus had 12 disciples. There are 12 months in a year. The tribes of Israel are 12. And then the first time Jesus preached in a temple, he was 12 years old. And there's a story of that woman who had an issue of blood. Blood was oozing for 12 years. So 12 is a number that we find frequenting the Bible so much. That's why I chose it as an example for this particular case. And 12, we want the factors of 12, the numbers that divide exactly into 12 without leaving a remainder. And we have 1, we have 2, we have 3, we have 4, we have 6, and last but not least, we have 12 himself. All right? So, panobvunzwa nyaya dzekuti ma-factors ndeanani, kuti ma-factor manhamba anopinda mune number asingasiye remainder. Ndofunga tiri kunzwanana ipapo, hatiri kuzoramba tichiramba tichiemphasize zvinhu izvozvo. We talk once, we listen twice. That's the reason why munane 1 muromo ne2 nzeve. Totara ka 1 uchinzwa ka 2. Ndofunga tiri kunzwanana ipapo. All right. So, the next aspect now is about common factors. All right. And by common factors, we are talking about factors that are shared by 2 or more numbers. My factors are shared 2 or more numbers. Let me take, for instance, Dr. 12 wandambo chuza uya, Dr. 18. And then the question requires us to find the common factor between those 2 numbers. So one of the things that we are going to do is we're going to list the factors. Factors of 12, we already listed them up. 1, 2, 3, 4, 6, and 12. Factors of 18, numbers of 18, see remainder. We're talking of 1, we're talking of 2, we're talking of 3, right? We're talking of 6, we're talking of 9, and then we're talking about 18, him or herself, right? And then to attend this is what is the common factor at 12 na 18. Common factor at 12 na 18, to kutarisa out my factors are kushewa ne both 12 and 18 the happy. If you check the factors that are common on 12 and 18, you have 1, you have 3, 2, you also have 3, you have 6, right? These are what we call the common factors, all right? So among the common factors, we also have another unique number, which is called the highest common factor, which means the highest number among those common factors. And in this particular case, our highest common factor is going to be 6, because 6 dear factor hombe iri apply pana 12 na 18. Ndofunga tiri kunzwanana ipapo viewers across the world. Anditi pozvo zvatutaura izvi zvinhu zvakapata izvi, asi zvinhu zvekuti kwa zvingamboye zvogozha kana chichichi aiwa zvinhu zvakapata izvi. Right, let us proceed further. So now that we talked about common factors, right, let's look at multiples, right? So a multiple is a number that you obtain by multiplying a number by a whole number. I understand ndofunga tarashana nevanhu because chirungu chakayana ngara ichi chimwe chakateukira mugungu handiti. Saka regai nditaure norurimi rwamai handiti kuti zviite clear to most of us kuda vanogona kunge vakarashikirwa nechirungu pachakateuka mugungu. Right? Kana tichitaura nyaya yekuti multiple, I'm talking about a number inopindwa nemwe number isingasiye remainder. Regai ndipendomenzaniso. Factor inumber inopinda mune imwe number isingasiye remainder. Then multiple inumber inopindwa. Saka handitaure tese 1 2 3 go factor inopinda. Multiple inopindwa. Katakize futhi zvakare pull over selector DJ Chico squared pandi place. Factor inopinda. Multiple inopindwa. Satikati isusu tuna multiples atu zvazviri kureva ndozvokuti tiri kuda nhamba dzose dzinopindwa na 2 asingasiyi remainder. Saka nhamba dzinopindwa na 2 asingasiyi remainder ndedzipi? Tikada kudzilista tatu 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 tichinda takadaro. Ndo nhamba dziri kupindwa na 2 ndo atiri kuti ma multiples iwayo. Ukazi ma multiples a 5 ndapi? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60 zvichienda zvakadaro inumber dziri kupindwa na5 asingasiyi remainder. Factors of 6, 6, 12, 18, 24, 30, 36, etc. Number dzose idzodzo dziri kupindwa dzisingasiyi remainder ndo atiri kuti multiples. You understand? I hope this is as crystal clear as a sodium chloride molecule. Let us proceed further. Let's move on to the rational and the irrational numbers. All right? So, by definition, a rational number is a number that can be expressed as a fractional form. All right? Let me explain further because I know some are moving in a parallel trajectory. All right? So, rational. All right? So, by rational, right, we are talking of numbers that can be written in the form A over B, right? In mathematics, A over B, we are talking about a number that is being written as a fraction, where A is a numerator and B is called a denominator. So any number that can be written as A over B is called a rational number. And in these particular circumstances, B cannot be equal to 0. B cannot be equal to 0, meaning to say a number, you can't divide a number by 0 in mathematics. It's called undefined, all right? It's unheard of. It's like handling trimethyl tetrazolium chloride without wearing a lab coat. You can't divide the number by 0. Azvife zvakaitika izvozvo. Adi munopawa. But izvo zvaishamisa zvoti vanhu vazhinji vandakafundisa vose maform 4, maform 5, nemaform 6. Unomubvunza 3 divided by 0 ndiyani? Unonzwa mwatari 3, mwatari 0. Saka vanobvunza mubvunzo naiwe kubva zvawakabva grade ECDA kusvika grade 7 uchibva grade 7 usvika form 4 pane pawakambonzwa here zvichinzi number yakambodivhaidwa na0 ever since? Ndopaunoona kuti bwai munhu akungoudya maziso sekatsi yadzipwa nesifa remukaka. Hakuna number inodivhaidwa na0 chibva imanzwa inini kubva nhasi. So rational numbers, these are numbers that can be expressed in fractional form, and these include integer ose atachibhotaura aya whole numbers. All right? They are rational. Because numbers whole numbers anokwanisa over 1 kumucheto kwazvo. Tobva taita terminating decimals. Right? Anonzi terminating decimal, decimal number anoguma. Zvakafanana noti ndikanzi inini ndina half da kumuchinja into a decimal number. 2 into 1, 0 point, we add a 0, 2 into 10, 5. 0.5 yatopera ichakwanisa kuramba ichiinda mberi. And this one is called the terminating decimal. So all the terminating decimals we have, they are part and parcel of rational numbers. And then my recurring decimals, they are also part and parcel of rational numbers. Let me explain to you what a recurring decimal is. A recurring decimal, I think the word is self-explanatory. Recurring, for example, 1 over 3 indian, 3 into 1, 0 point, you add a 0. 3 into 10, 3. Right? Remainder what? 1. 3. Remainder 1. 3. 3. 3. Ma 3 aya acharamba achingorikea kusvikira zuva rinodzoka mwanakomana waMwari Jesu Kristu. Saka ukaona fraction yakadero yoti uramba ichingeinda mutorododo guyo gwegweru wobva watoziva kuti we are dealing with the recurring decimal. Saka recurring decimal tatichii pamusoro pakagara zviya, recurring decimal iri part and parcel of the rational numbers. All right, let's look at the irrational numbers. Right? Irrational numbers, numbers you can't express in the form A over B. You can't express those numbers as fractions. And my irrational numbers. So my irrational numbers are going to include that. Right? One, are going to include that my non-terminating and non-recurring decimal numbers. The decimal number is going to be numbers that one is called an irrational number. And then secondly, Tonight my sets. By sets, we are talking about my square roots, my non-perfect squares. We talk of numbers like square root of 2, square root of 5. These are called sets, all right? And then we also have a number, the pi. Pi, right? Pi is a Greek letter of the alphabet, normally approximated to be 22/7. And the pi is an irrational number, all right? Last but not least, let's look at reciprocals, all right? So, katika nyema reciprocal, all right? Right, let's look at reciprocals. So a reciprocal, by definition, reciprocal of a number is 1 divided by the number. So what is the reciprocal of x? The reciprocal of x is 1/x. What is the reciprocal of 3? Reciprocal of 3 is 1/3. What is the reciprocal of 2? Reciprocal of 2 is 1/2. What is the reciprocal of 4/3? Remember, reciprocal that is 1 divided by the number. So when the reciprocal of 4/3, we're 1 divided by 4/3. Then we divide them fractions. We are going to invert this fraction 4/3 into 3/4. After doing so, the division sign changes to the multiplication sign. So the reciprocal of 4/3 is precisely 3/4 on the basis of the definition of a reciprocal, which happens to be 1 over that particular number. Viewers across the world, I think I have emphasized enough anesheve answer, because that sanangura ndichishandisa my muscles from all parts of the body, and let me repeat, from all parts of the body. And it is my hope and belief that whatever information that was disseminated has found fertile soil within your brain and your mind, so that it germinates and grows into a fruitful fruit that you are going to use in the future. If you have any questions, any comments, any suggestions, any contributions, any queries, any misunderstandings, any misconceptions, any nimbus stratus cloud of confusion, or rather any cumulonimbus cloud of confusion, share with us your thoughts in the comment section. Be sure to like, subscribe, and share this video to as many people as possible, so that we can emancipate people from mental slavery. Viewers across the world, Chico Squared, Maths and Science Guru. Chakwenda chibaba, chapeza icho. Woyo.